Hi, welcome back. So let's now continue our discussion to the introduction to physics. We are done with our first part, the introduction, discuss what is physics is, the branches of physics. Also, we're done with the units of measurements. So now let's move on to our last topic, which is about the scalars and vectors. Okay. In physics, we have so many physical quantities like force, area, mass, weight, velocity, heat, power, what else? Temperature, pressure, displacement, and so on. So all those physical quantities can be described either with magnitude only or with both magnitude and direction. So that is what we call the scalar and vectors. So when we say scalar, these are physical quantities or quantities only. Quantities with magnitude only, while vectors are physical quantities or quantities with both magnitude and direction. Okay. So the main difference is that the scalar quantities are with magnitude only, and vector quantities has both magnitude and direction. For example, we have the box here, which is being pushed with a force of 100 Newton. So our example is we have a quantity which is force pushing this box to this direction. So it shows that the force is a quantity with both magnitude, what is the magnitude of this force, we have 100 Newton, and direction, what is the direction of the force, we have it is indicated by this arrow here, meaning that this force is pushing this box going to the right direction. Okay, so meaning that a force directed to right direction would be different from a force directed to the left direction. That's why this makes sense if we are talking to vectors, because in here, specific examples of course, the direction matter, because the response of this object to this force would be different if the force is if we push this box going to the right with this amount of force, and if we push this box going to the left direction. So the first example here is that when we push this box going to the right direction with 100 Newton force, maybe the response of the object will be somewhere, would go somewhere to this direction. Okay. Also, this will make sense when various forces are acting on this object. Example, there is a force going here, and also there is a force that is pulling this box going here, or pulling this box going here. Okay. So if there are many forces acting on this box, to where would the object move? Okay. So it is to the right, to the left, going to this direction, and so on. So it depends which force is greater, or it depends on the summation of the forces acting on this box. So that's why direction matters on this aspect. So for this certain example, force is an example, or force is an example of what we call a vector quantity. Okay, because again, this quantity here has both magnitude. What is the magnitude here? The 100 Newton, and the direction is going to the right, and going to the about 45 degrees from the x-axis, and so on. Meanwhile, when you notice that this box has what? Has mass. For example, the mass of this mass is about 10 kilogram. Okay. So in here, if we apply a force going to right, up, or left direction, it doesn't matter, or the mass of the object doesn't matter whether it is being pushed to the left or to the right. Meaning that this mass has only the magnitude. So the quantity mass is an example of scalar quantity. So it only has what? It only has magnitude, which is 10 kilogram. So there are other physical quantities with both magnitude and direction, and with magnitude only. So some other quantities, or for example, we have scalar quantities. We have an example, distance. Okay. So distance is an example of a scalar quantity. For example, the distance between two objects, object A and object B, is 5 meters. So it only has magnitude, which is 5 meters. And another example, we have mass, like what our example is. Example, the mass of the object is 10 kilogram. Also time has no direction. 10 seconds, 15 hours, and also speed. Example, 100 meters per second is the speed of the car. And also we have temperature, 10 degrees Celsius, negative 15 Fahrenheit. And here in temperature, the positive or negative sign doesn't mean that the temperature is going somewhere, but it only means that the temperature has going up or going down with this positive or negative sign, but it doesn't mean that the direction of this temperature is going to the right, going to the left, or whatsoever. Okay, so the positive or negative sign here is only the scale of this temperature here. Okay, so temperature is an example of the scalar quantity. Okay, and so many more. How about for vectors? So we have, for example, displacement here. For example, this box A here displaces about 5 meters. Okay, so if you notice the scalar quantity here, distance, the distance of these two objects from point A, or any distance of point A to point B, is 5 meters. But here, with the displacement, we see that this displacement is a vector quantity. Since it means that this object A here displaces about 5 meters from this point up to this point, going to this direction. So it displaces about 5 meters going to this point. So that's why the displacement is a vector quantity, since it has both magnitude and the direction is it displaces 5 meters going to the right direction. And sometimes they use positive or negative sign to indicate the direction of the vector. For example, from our initial point, instead of going to the right, the box displaces about 5 meters, but on the opposite direction. That's why we include a negative sign here, which means it displaces 5 meters going to the opposite direction. And another example of this vector is that we have a weight. Example, we have 98 Newton. Okay. So weight is a vector quantity since always the weight of an object, it is the product of the mass and the acceleration due to gravity. So always the weight of the object is always always pulling downward due to gravity. That's why weight is a vector because of the gravity pushing this, or pulling these bags having a mass of something. Another example is between speed and velocity. So in here, when we say the car has a speed of 100 meters per second, it only measures how fast the example how fast the car is moving. It's about 100 meters per second. But when you say velocity, the magnitude of 100 meters per second must correspond with a certain direction, either positive, negative, or going to the right, going to the left. Okay. Example, we have a car here with a velocity of 100 meters per second going to this direction. So we can indicate the velocity of the car being positive, it is going to the right direction, or when we say that the velocity of the car is about negative 100 meters per second, which only indicates that from our reference point or direction, it goes to the opposite direction. Okay. So that is the difference between the speed, which only has magnitude, and the velocity, which has both the magnitude and direction. So this car is moving 100 meters per second going to this direction, and that is velocity. So that's all for the introductory part of this scalar and vectors. So for the next video, I will be discussing on how to operate or how to add or subtract vectors.